Did anybody see how many people were signed up? I didn't look.
I didn't see.
I think it was about 25 or 26.
As a general rule, it's typically around 30 to 40% of that number show up usually. So
yeah,
we'll just wait a few more minutes. Oh, thank you for reminding me. Yeah, I actually am going to be recording this. Oh, it's actually recording automatically. So it's actually recording automatically. I don't know if you can on Zoom do a separate recording. But if you have something like an external recording, you want to record it, that's fine. This will be posted on the ai-forall website. That's the one that we're started with the ai-forall podcast, which I also sort of create and run with a number of other people. Okay. Yeah, we'll just get started here. I don't know if this is going to be entirely an hour for this session, guys. So this is probably going to be maybe around 45 minutes or so. Just as sort of a quick introduction of what generating reality or generative modeling, essentially, what we're going to talk about. This picture that you're seeing here, you should be seeing, is an example of generative modeling. It's an example where we've taken a number of images, sample images that have been fed into a deep learning model that's been trained, and then what you're seeing is sort of the model being walked across what we call the latent space. And I'll talk through all this stuff, but sort of what you're seeing here is exactly what the model has sort of been designed or trained to see. And now all those little sort of creepy faces are sort of the in-between areas that don't make sense sort of thing, but there's actually an answer, or there's an actual picture, I guess you could say. Okay. So a little bit about me. I just finished my 7th book called Practical AI on the Google Cloud Platform. Any of you follow me on LinkedIn, you've probably seen that. This Friday, I'm going to be giving away 25 ebook copies for reviewers. And then probably in 3 weeks, we'll be doing another 25 print copies for reviewers. So that's Amazon reviewers. So if you're interested, just follow me on LinkedIn. And when that announcement comes out, just be one of the first 25 people and you can grab a copy. I'm just going to mute a few people here. That's okay. But feel free, if you have any questions, feel free to jump in and ask your question at any time. So I've got 20 years of experience in AI and ML. A lot of my previous experience or success, I guess you could say, is with genetic algorithms and gene expression programming. But for the last 5 or 6 years, I've been spending a lot of time doing deep learning and working with deep learning. My experience, particularly in generative modeling, is where I developed a GeoAgent, which is essentially could look at subsurface visuals or log displays, and then project what that would look like in almost real time to geologists sort of to see what that prediction might be in real time. So what the subsurface might be to look at real time. And they would use this for horizontal drilling applications. If you work in oil and gas, you'll know that horizontal drilling is was the big trend, may come back to being the big trend because it's efficient. It exposes a lot more of the subsurface to potential production, that sort of thing. My background is in oil and gas, but I've been since moved or transitioned to financial, I guess you could say. So I'm sort of working on other problems right now, so I'm not really spending a lot more time in oil and gas. But if you have any sort of specific questions to oil and gas, I'm not bound by any contracts or stuff like that. So if you want to talk offline, we can certainly do that. Okay, and I originally founded the Calgary Deep Learning Meetup, but that had grown to about over 1,200 members. We would get 60 to almost 100 people per session. And it was just really interpersonal, especially with COVID. So what I wanted to do with creating a new meetup was allowing sort of a group of people to sort of help me with my next book, which is what this meetup is actually about, but also sort of learn and be a lot more hands-on in the learning they do. So this first session, I'm going to talk about just a general introduction, just to see if that piques your interest, or if you know if it sort of piques somebody else's interest, and you can let them know. Generative modeling may not be for everybody. It has certainly, certain specific applications right now, but it really could do a number of different things. The GeoAgent is just one example of that. Deep fakes or other things like that are just other examples of that. Okay. So this is a new meetup, and as I said or hinted at before, the theme of this meetup is really about sort of walking through, as I'm writing my next book called Generating Reality, which is about using techniques to do generative modeling from basic things of generating images of food, for instance, to all the way up to creating deep fakes or even doing more advanced things. So that's the whole intention of this. We will look at sort of concepts of deep learning, some other things to get you guys up to speed, but our ultimate goal is sort of building working applications that we can toy with and play with. Okay, so that's really the goal of this meetup. Anybody have a question? Oh, Yogi.
Yeah, I just wanted to know if you want to move to presenter or display mode rather than stay in edit mode on your PowerPoint.
Yeah, I was thinking I didn't want to. I know it's maybe, if it's okay for everybody, I wanted to stay in this mode because I might be switching through, and I have a number of GIFs that I want to maybe turn off or on. So I wanted to stay in this mode, Yogi, if that's all right.
Just fine by me.
Okay. Okay. So really, the main rules of this meetup are, I really want to encourage people to be hands-on, participate in what we're doing, playing through all the sort of collab notebooks. We'll be using mostly collab notebooks because not everybody's going to have the horsepower and the machines to train models. Collab is an excellent platform. It offers, free GPU programming. So we'll be doing most of that there. And the other thing is I also want to encourage everybody sort of that attends to maybe not be afraid of sort of demonstrate some things that they've worked on or helped or cool things they've made or stuff like that. I'd really like to have this meetup be that type of meetup where we can sort of help each other out, present things and stuff like that, all around the vein of generative modeling, essentially. So let's talk about generative modeling. This is an example of generative modeling being applied to static images. And here we have a static image of the Mona Lisa. And on the side here, through generative modeling, we've been able to apply video of somebody talking and then apply that through transformations, essentially, to animate the picture. You've probably seen plenty of examples of this, Leonardo da Vinci or a whole bunch of other images. So this is an example of generative modeling. Other examples are, this is where I was sort of hinting at before, where you have an input image that might be sort of fuzzy, and then you can rescale it or upscale it. You can upscale the image or downscale the image. So we're talking like, the old Blade Runner thing where they're doing enhance and stuff like that, where they, even movies or TV shows when they're saying enhance. And everybody's like, well, you can't enhance that. Well, with AI, there's a possibility you could enhance it. Whether it's an actual correct image or not is sort of iffy. For instance, they've showed fuzzy images of Obama, I think, and it came out to be a white person. So generative modeling has a fair bit of ways to go. And it really depends on the amount of data or the amount of images that you train on it, and the quality of the images and sort of the distribution or the type of images you're training on. Okay. You've seen, this is another example, that animating faces piece. So this is another example of generative modeling. So this is the types of things we look at and play with. This is the type of things we'll be sort of looking at and playing with in the meetup. And then we have examples of maybe the ultimate of this course will be doing deep fakes, or being able to create your own deep fakes for things, or even being able to use a thing called Adversarial that can use or swap out your face in a Zoom call, assuming you have the proper horsepower in your machine. So this is another examples of generative modeling. There's tons of these out now. You've probably seen, they've been out for a few years now. Very popular. The technology is just becoming so popular now, though, they're so accessible that creating these things are quite easy to do, and they're just getting churned out in lots of different things. I guess porn is a big one, but we won't be doing anything with porn. And this is an example of what I was talking about with Adversarial. It allows you to essentially take a static image of, or static trained image set of somebody and apply your mouth movements or whatever, and you could essentially look like the Mona Lisa, Einstein, Steve Jobs talking through your Zoom call, essentially. So that would be a piece. I was thinking about demoing that, but I need a machine probably with a little more horsepower to do that in real time. Okay, and here's another example where this is the Adversarial being done in real time here with the person over a number of different images. You can see all the kind of cool things you can do. Some of them look better than others, obviously, and a lot of it's all going to depend on the training data. And here's another example where we'll talk about various forms of generative modeling. Everybody, typically you'll think about generative modeling as what we often refer to as generative adversarial networks, or GANs, but there could be other versions of generative models, variational autoencoders, to this example here, which is adversarial latent autoencoder. Okay. So the basic premise really behind generative modeling, just looking at all those previous examples, is we take a bunch of training data that describes images spread across some space, right? So you'll have female, male, people with glasses, people with short hair, long hair, whatever. You could all think about them sort of mapping across the space of your model. What we do then is we sample these images, we sample from that model that we build up, and that's able to generate for us very realistic images, but of people that are not real. So essentially look at that space in between the areas. So we might take a sample from this space here, which might have some red hair, female trends or stuff like that, and that might extract a female person. Whereas this space down here in the space would generate a man with a bit of a scruffed beard, etc. So that's sort of basic underlying principle in generative modeling is you have this training set, you feed it in, you train your model, and then from the model, we can extract from the latent space new samples or new information to generate new realities or new conditions. And we'll look at some ways we can control that generative modeling ability. Anybody have any questions yet, or want me to touch on anything before I go any further? No? Okay. Okay, so there's, like I mentioned before, there's various techniques: autoencoders, variational autoencoders, generative adversarial networks, adversarial latent autoencoders, and there's others. The number of GANs has increased from 1 in 2012, I think, when it was first discovered. I think there's almost 1,000 different variations of GANs. Some of them might be minor variations, but some of them are quite major. A lot of different variations of GANs now that you can play with and look at that could do all sorts of applications, for instance. Okay. So I'm just going to look at a couple examples of what we would often refer to as generative generators. And the common one we'll look at, or you might have heard of, is the GAN. So this is an example of a generative adversarial network where we have two models. One is the generator model, and one is the discriminator model. We often refer to these two models as the art critic or art authenticator being the discriminator, and the generator as being the art forger. So the art critic or art authenticator takes a bunch of these real samples and fed in, and it's trained on real samples to recognize real samples. If it gets it wrong, it's essentially punished and said, no, you're not correct. You need to adjust your training a little bit. If it gets it right, it fine-tunes it. And likewise, the generator is just generating from a random latent space. And in the basic vanilla GAN, all we're doing is feeding just some random latent space into the generator. And the generator's role is to build an image that can fool the art critic into believing it's real. And through that process, the generator is able to, from a vanilla GAN, is able to generate from nothing, essentially an image that might look like a face, or it might look like, you know, all sorts of different things. I'll use faces as sort of the common analogy that we often sort of see as these type of things. But as an example, there was a company, a startup in France, who fed a GAN, it was just a vanilla GAN, a bunch of art images, several thousand, maybe a million or so, and then it generated this image, and then it sold it up for auction. And this image here, and you can see it's signed, and the equation here is actually the GAN equation, which represents essentially the probability distributions. We're not going to get into that tonight. But this painting here sold for 400,000 euro at an auction in France. Now, admittedly, it was probably a bit of a gimmick because it was to maybe fund the startup in some ways, but it's just interesting to see that this image here was generated, you know, completely from the computer, and it, you know, it's just funny how far some of these things would go. Okay, and then, like I said, we're going to try and keep a bunch of the math light. There's all these sort of equations that go with some of this stuff. We're going to keep it somewhat light, but more sort of define the intuition of what's going on with the math, so you can understand maybe what something is doing wrong or when it's doing wrong. But I always encourage somebody to sort of look into these things on their own time and spend some time. A lot of our approach, though, will be sort of looking at code, spending time playing with code, and seeing how these models work from a sort of practical application, or getting them up and running, essentially. Okay, so our path is really going to be, to start with, is to understand deep learning. Deep learning is going to be the foundation for most of what we'll cover through this course. So we'll be using Python, and from there we'll sort of build generative models, all sorts, from autoencoders, variational autoencoders, to GANs, convolutional, dual convolutional, to conditional GANs, etc. GANs can be notoriously difficult to train, so we'll spend a little time sort of learning how to tune hyperparameters, learning how to structure models, and learning how to sort of understand when a model can get too big and how we can fix that effect. Just to sort of overcome those issues so that we're not all discouraged when we go home and we try to train these things. We want to make sure that you guys are successful. So we want to spend a lot of time training these things and understand how they work. And a big part of that will be understanding how we tune hyperparameters, or how we structure the model, or introduce other layers that can sort of compensate for effects or differences, or things when things blow up, essentially. And then we're going to learn to sort of expand on these models, identify some stuff, and then hopefully at the end here create some cool stuff. Okay, so a big part of this, the next session, for instance, will be sort of a basic introduction to deep learning. We're going to look at PyTorch. We're going to look at the sort of the basics of all the deep learning networks, how they work. That'll be sort of important to understand a lot of the basics, how they work. We'll talk to backpropagation, you know, optimizers, how networks train through gradient descent, stochastic gradient descent. We'll talk about problems that can happen in networks, like vanishing, exploding gradients, how we could fix those with regularization, overfitting, underfitting, and how we could fix those with dropout. Understanding loss and training, and then how we can sort of walk through, understand the latent space of our models, and how we can sort of look to or understand how we can generate content or new content from those latent spaces. Any questions? Just a big slide. I don't want to scare anybody off. No? Okay. So as I mentioned, we're going to be using PyTorch. TensorFlow was an option as well. My last book was actually entirely in TensorFlow. This book is going to be in PyTorch. The previous book to that was actually in PyTorch as well, which was with reinforcement learning. The reason I choose PyTorch is because PyTorch is typically more researchy and more sort of cutting edge. So we want to be at sort of that forefront, and using PyTorch will allow us to do that. So if you can use PyTorch and you can sort of learn how PyTorch works, we can look to sort of pulling down repos from GitHub and learning how to set those up quickly, being able to set them up and work through them and stuff like that. By no means am I thinking that, you know, you guys are going to be able to write these things from scratch by the end of a couple sessions. But I think, you know, being able to pull stuff from Git and playing with it, using it, being able to modify it to your needs to a certain extent, I think is entirely possible. And I actually have an example here at the end of this presentation with a demo that I can show you that is an excellent place to sort of start with this, see if you want to continue with this. And lots of code samples. So for all my books, I have tons of code examples. I'll be sharing the code with you guys online so you can look at it and play with it. And it's one of the reasons why I'm doing this as well, is so that we have some feedback on the code, how it's going, is it working well enough, does it convey the concepts well enough, etc. Okay. And I don't know why I put the learn the basics of regression classification. Okay, so, and a big part of that, as I mentioned, is going to be learning how to train networks and tune hyperparameters. Generative modeling can be notoriously difficult to train, and it has to do with a lot because what you're doing often is you're often doing what's called adversarial training. So even if it's not a GAN, if it's some other model, you'll often have sort of two networks that are sort of competing with each other. And as they're competing, you'll start off with your forger that's trying to create those images that are fooling the art critic, but you don't want the art critic getting too good at spotting fake images before the generator can train up or learn. So they actually have to learn in tandem, and that's where you have to sort of do this balance mechanism. And you have to balance these two networks, and the two networks are often almost inverted to each other because the generator is generating an image of 28 by 28 or 60 by 60 pixels, where the discriminator is taking that 60 by 60 pixel image and it's digesting it down to some basic classification. Is it real or fake, for instance, or is it real or fake, or does it match these conditions? So those two networks can be very different, and understanding how they work and stuff like that can be a little tricky, but I don't think, we'll be looking at a number of examples, so there'll be lots of exposure to these types of things. Okay, and then learning, like I said, how GANs work, how to fix training issues, manage multiple training networks, as I mentioned before, how to spot issues. So what these diagrams here in the showers on the side are showing you is how the loss, we want to balance the loss between the generator and the discriminator. The generator, again, is that art forger, and the discriminator, again, is the, you know, the art critic or art authenticator. You can see, you know, for a good training cycle, we sort of want to balance our loss. We don't want to get one network that's sort of training very well or one network that's training very poorly. Okay, and then we'll look to create. So a number of the things we'll be looking at, again, as I mentioned, variational autoencoders, generative adversarial networks. We'll look at, you know, tons of variations of that. We'll look at dual convolutional GANs, conditional GANs, pix-to-pix GANs. That's where you take one picture and you try to map it to another picture. Cycle GANs. So what you're seeing here in the video, or this GIF, is a example of a cycle GAN or cycle consistency GAN. I'll talk to that in a little bit. Or self-attention GAN, like the Oldify, deep fakes, and this Adversarial feed. Okay, so in the case of variational or autoencoders, essentially you're working with two networks that one feeds into the other, and you spit out an answer. So in this case, the basics of generative modeling uses essentially the autoencoder model or variational autoencoder. And you can take a GAN and you can actually split it in half down the middle here and sort of turn the pieces outside. It becomes the same model. So the encoder takes this image, encodes it down to some representation. In this case, it's showing a variational autoencoder where it's reducing it down to some distribution, where that distribution is reversed, decoded back into the digit. And that's the first thing we learn how to do, is to generate that. By understanding this distribution, or how the data is sort of mapped across that space, then we can sort of alter the parameters here and then generate other numbers or other areas across that latent space. And that's the first part that sort of teaches us how to sort of generate pieces across that latent space of what our model learns. Any questions? And we'll get into more of this stuff. I think the next will probably end with working through a variational autoencoder or an autoencoder in exercise, for instance. Okay, so here again is the GANs, where you're seeing the real faces going to the discriminator, and you get this random noise going to the generator. It's generating faces. You need to sort of, and then the discriminator or the art critic or the face critic in this case needs to determine if they're fake or real. And that's, you know, just a really simple example of that. And this is sort of the example of the network. So you can see this, the network is actually larger on the discriminator when the input's coming in, and then it sort of breaks it down to sort of two outputs, whereas this random noise comes into just a couple neurons, and then it expands up as it goes through the network into an actual face. Okay, to dual convolutional networks, so we'll talk about convolution, how convolution works. We'll be using convolution for a number of things, for image creation or image, you know, understanding images, dissecting images, or feeding them into the model. We'll talk about conditional GANs. So conditional GANs is where we take or we train our models based on the conditions. So for instance, if we had faces of people, we might train them on conditions of male versus female. We might train them on conditions of somebody's wearing glasses or not wearing glasses, or facial hair or no facial hair. And those are all conditions we can feed into the model. But then based on that model, we can actually train our generator to then generate those images based on those conditions. And that gives us the power to say, oh, I want somebody generated with glasses, or I want somebody generated with facial hair, for instance, or somebody with male with facial hair. That gives us a control on how we can extract from that latent space what the image we want, and it sort of generates that. So we can mix and match those attributes, and that's sort of the power of a lot of these models. And then we have sort of these, the pix-to-pix can, where we're feeding in images essentially, mapping them to an output. So this is the input. This is the truth that we want to train it to. And then when we sort of generate based on this input, it's giving this actual output. So we're essentially training the model in these two images, much like a sequence-to-sequence learning or machine translation model, where it's learning these two truths, and then it's able to output this other truth. So you can see it sort of picked up this, and then it sort of generated this other picture entirely from that. And then you have this cycle GAN, which is another example of a generative model. In this case, a cycle GAN uses a concept of, say for instance, you wanted to translate something from English to French, but you didn't know what the translation would be. Well, if you translated it to French, and then from that French translation translated it back to English, you could understand how much off you were from that first translation. That's essentially how a cycle consistency GAN works. So it's actually taking your first statement, doing the translation on this side, but then that translator returns part of that into an English statement, and then you determine how much loss. So you might say, hi, how are you? The French translation translates into French, then it translates it back into English and throws it back, and it might say, I am good, which is entirely wrong. That means you punish your model and you sort of correct towards that. So that's how we work through cycle consistency. And the nice thing about that model is you can do all sorts of real cool things with images, well, paired images, where you're saying this image might map this one, but you don't have to necessarily know how to get there. The cycle consistency will train you on how you might translate that, or how you translate. So in my example with the languages, eventually your model would be automatically able to translate to French correctly, because it understands through its own loss on its English conversions back how it would actually need to translate that correctly back. Okay. And then, so here's another example where cycle GANs come in use, where you're taking a satellite image and you might want to actually generate a map like this, you know, street map essentially. And you can train that. What it's doing is it's understanding the loss in its images, so what it needs to sort of correct, and through that it correctly creates these types of images. So it's really cool. And you can do other things where you could sort of identify areas in here where you might be identifying, sorry about that, might be identifying some interesting place or something. So you'll put a box around it, for instance, and then your map or something like that could do that as well. We'll look through some examples of that. A lot of good practical applications with the cycle GAN because it's nice to easy to set up, and it can do a lot of nice things with GIS or geological samples or pictures of geological samples, for instance, and some other really cool things about that. Okay, and then we'll talk about self-attention GAN and this concept of attention. If you've heard anything about GPT-3 or any of the new language models that use what's called a transformer with attention, that uses some of this attention concept where we progress a little bit from convolutional, which are using to extract features in a local sense. So convolutional allows us to extract features that are localized, meaning it'll pick out an eye in a picture, but it won't necessarily pick out that eye in relation to other things. And it's nice for us to have that understanding of how that eye relates to other things. So we think of convolution as a localized feature extraction piece, whereas attention can work as a global feature extraction piece, meaning it gives us context to how a feature is extracted in the whole big context of an image, for instance. And that gives us some really cool and powerful features. So here's an example of Deoldify. And Deoldify is a project that was made by just a developer called Jason Antic. And he developed this project using a self-attention GAN. Essentially what it does is it colorizes old images or videos using the self-attention GAN. So he's trained it on what this sort of conversion would look like between a black and white image and a colorized image. And then from this, you can train other images into it. So you can use this Deoldify to actually colorize all your images or colorize your old videos and stuff like that. The problem with this is you can see that most of this is working really well. And if this was a convolutional model, we'd see some issues or problems. The other problem we can see is what's called zombie skin, or that's what the developers call it, zombie skin. As you can see, his hand here is actually blending into the wood. So the self-attention in this particular example isn't necessarily working as well as it should be. And that's probably some of the training. And I think they're working on resolving this issue. But that's sort of an example of some of the shortcomings in this particular model. And here's an example of another Deoldify picture where we're looking at, it's a colorized of the, what's this called, Metropolis, I guess, the movie, where it's colorized. And you can do all that. And I have a demo of this a little later. I'll show that to you after. So here's an example where we have deep fakes. And what we're doing here is the actor's been training, and then we're using the input images here to actually determine what the face is. So this is the individual talking, and then we're superimposing the face over each of these. And that's sort of deep fakes. And ultimately, I hope to get there near the end of this. Okay. More examples of deep fakes. In this example here, this is about determining what is a deep fake and what isn't a deep fake. I guess some of the things they're looking for now is your face will get, you can actually see the blood pumping through your face. You should be able to see your face changing colors as it's going through the video. So that's some of the techniques we'll look at maybe in sort of how to spot deep fakes, et cetera. And then ultimately, hoping to get into an example of using Adversarial to do some of this real-time, being able to map your face out and doing some cool stuff like that. Okay, so really the requirements, or hopefully the requirements for this are, you should have a knowledge of Python will be really helpful. Some knowledge of NumPy will be useful. Exposure to Jupyter notebooks. Some understanding of data science or be comfortable in that area. Even a basic course in data science will probably help you out a lot. And a lot of it's going to be, people ask me why data science? And a lot of it's because a lot of the terminology I'll use and stuff like that is sort of adapted from data science. Deep learning, it's been around for 50 years, but a lot of the big increases or big big things that have happened since have all been wrapped more around data science. So a lot of it relies on data science, and data science techniques or things we'll talk about, such as mean squared error, for instance, and other things like that. So that basic knowledge. And what I should have added here is linear algebra, calculus, and statistics, but that sort of follows with data science. Okay, any questions? And then I was going to jump into a quick demo of Deoldify and how you guys could use it. Any questions?
Hey, Michael, thank you. Thank you for this. This is really awesome. I was wondering if you could touch a little more on maybe what sort of non-image uses in generative models would be. Like I think I've heard of fraud detection. Maybe you were touching on even translation, which I thought would be like kind of like an LSTM problem, but I guess you're using it now for.
Yeah, so for any of the natural language models, most of them have gone to transformers with attention for any sort of language stuff. LSTMs are more typically regulated to time series prediction and stuff like that. They do have some use for NLP prediction and stuff like that. I mean, in some of my courses, I still teach them, but reality is that most of the mainstream stuff is going away from recurrent networks for NLP processing or natural language processing. Does that help? As far as other things that you might do with this, you could think about, one of the things I sort of talk about is, say you had an image of the state of your power plant or your car or something like that, and maybe it was in colors, so it was nice and easy for a machine to understand, but it might expose one state, say the gas level was a certain level and all this stuff. You could take that state, and through that understanding of that state, map other states in. So map other states into maybe when the car is breaking down to when the car is running perfectly, etc. Taking all those states, and then you could feed your current state in, and it could predict or give you what your actual condition of your vehicle was, right? So it could essentially extract from what it had learned previously and to give you what your actual vehicle should look like, or the state of your vehicle should look like, say in 5 years or 10 years or whatever. What the predictive state would be. But as a whole picture, yeah. And a lot of other applications. People are starting to use it for language. Sometimes tabular or tabular analysis, some of it's been played with, but there's other issues with deep learning and tabular analysis having to do with discontinuities and some other issues that oftentimes we stay away from it. We often like to have our data nicely and not discontinuous. So that's one of the reasons why you'll often get tripped up with tabular data if you try and do some of these things. But if you have the right data set, it could definitely apply, yeah. Any other questions? No? Okay. Okay, so what I'm going to go here. So I'll just bring this up here and I'll show you where I've sort of sources from. So if you just go Deoldify, it's a project on GitHub. It's getting quite popular. It should be probably one of the first entries you come up with. And in here, there's a couple collab notebooks that are easy to pull up and you can use right away. So I'm just going to look at the image colorizer stable. This is the one I'm going to look at. And if I click it, it's going to come up with a notebook, but this is not where we're going to use it. I'm just going to wait till it loads. You'll see this blue button at the top that says Open in Collab. So I can click this button, and when I do so, it's going to open for me in Google Collab. And everybody should be able to have access to it. And this is basically the same as any notebook. It gives you a few more capabilities. Just go ahead.
You're still showing the slides. I'm not sure if you wanted to switch to your.
Oh, okay. Okay. Thank you very much. Okay, here, let me just, okay, let me just go back. Okay, so when you go into Deodify, let me go back. Are you able to see this now, everybody?
Yeah.
Okay, so I just did a Google search for Deodify. It comes up, and it's going to be probably one of the first projects. It's a GitHub project, so I'm just going to click on it. And in this repository, you'll see a whole bunch of files. The one I'm looking for here is the image colorizer collab stable. It's about halfway down, I guess. And I'm going to click that, and that's going to open up the notebook essentially, but we're not going to do anything here. There's this blue button on top, and I'm going to click that. When I click that, it's going to open up into Collab. So you'll get this view, and you'll actually have some documentation and some other stuff so you can look through. What I'll do first time here, though, I think if I just say runtime run all, I've had this running, so it won't have to reload. But what it does is it just pulls down from the repository into the notebook, so it's just going to pull everything down for you. Copies over. It pulls out all the stuff it needs to, and this is actually written in PyTorch as well, so it's useful. The other thing you want to make sure is if I go up to the runtime and I check the runtime type, I'm just going to make sure it's running GPU, because if this is CPU, it's going to run a lot slower. And this is the nice thing about Collab, is because it offers the GPU capabilities. So I don't have to change anything. I think it probably will be set to GPU automatically. So it's just going to install the requirements for the project. This is pretty much all foolproof. It's installing the other requirements here and these other code blocks. If you have to rerun code blocks, you can just click the button and it'll just rerun it quickly. Actually, I think it's waiting because it's training the model down below. So you'll see here it's getting the colorizer, it's starting it up. It might just take a few more seconds. But essentially, what you do is then from here, this block is the one that actually does everything in the notebook. And all you have to do is paste into an image, a link to an image, and you can get those links from the bottom of the sheet where you'll see there's the way we were from Reddit. So if you go to just the way we were from Reddit, and here's an image. If I right click and I just copy the image address, and if you have other sources images, you just have to put them up. So here's an example. It just finished training. This is from a previous image I did. So what I'll do is I'll just copy that new image of the kids of the pumpkin. And let's just run this cell again. So the whole model should be loaded. And what it's using is it's using a pre-trained model. So it's already using a pre-trained generative model. It's essentially doing the colorizing for us. All we have to do is just feed the image in to get it colorized. So I'll just rerun it again here. And this time it should be that new image that we just looked at here from here. And it generally just doesn't take very long. I think I've done videos where it might have taken, you can do videos or images here. And it doesn't really take more than a minute or so, typically speaking. Yeah, so there we go. So not the best, but not bad. And then it has this threshold factor called render factor that allows you to change and alter. So there you have a side-by-side comparison. So you might have to tweak that, but you can see, again, not every image is going to work perfectly. I've done a ton of images for my family in the 50s and 60s, and they worked out quite well. But yeah. Any other questions, guys?
How much data does this, for training, do you need in typical applications to, come up with a decent model?
Yeah, so the amount of training you need really reflects on how big your model is. So the bigger the model, the more training data you need. I think in this model, it's fairly substantial, maybe thousands, like 50,000, 100,000 images probably. But you know, there's becoming a lot more accessible data sources for that. Generative modeling as a term suggests there might be other types of modeling as well. I'm not sure I follow that question. Who's that from? Oh, Yogi?
Well, the title of today's event is Generative Modeling. So that kind of made me wonder, are there other kinds of modeling? Or is this a unique term?
Well, I think if you could think of sort of classification modeling, I sort of use the term generative modeling, or I've seen other people use the term generative modeling to sort of broad base this into a field of technology that looks at the specific problem for AI, I guess, as opposed to regular things. But I guess that's sort of, that's an interesting concept. I'll have to look at that. Yeah.
We talk about other kinds of modeling. You talked about subsurface modeling, and I guess we can talk about financial modeling, and
yeah.
You hinted at digital twins. That's a form of modeling. I guess maybe I'm just looking for a little more understanding. I mean, we're obviously colorizing as a way to generate colors onto a black and white image.
Yeah, so that's where I want to. So this is often the piece that sort of confuses people. So this is not a filter operation. This is not the model is applying a filter to it. It's actually feeding the entire model in, and it's regenerating the image. So it learns how to regenerate the image based on the image coming in, essentially. So it's not entirely a filter. You can almost think of it as a stream transformation process, I guess.
Okay, that's helpful. Thank you.
And the reason why I use typically, well, the reason why I've started using generative modeling to describe this whole area is because a lot of people generally think all of this is done by GANs, but there's a lot of other technologies coming about to do these types of generative modeling where you're creating new things from existing trained elements, I guess you could say. So it could go to financial models, it could go to subsurface modeling, it could go to a lot of other areas. Yeah, you're absolutely right, Yogi.
Great, thank you.
Any other questions, Ben? Okay, well, I just wanted to keep it as a brief introduction, short and to the point. The next piece will be sort of an introduction to deep learning, a little bit of exposure to PyTorch, just some ideas on how deep learning works and stuff like that. And then from there, probably further sessions, we'll actually dig into PyTorch, learn how PyTorch works, from basic, linear regression to classification examples, and then autoencoders, and then up from there to GANs and all sorts of other technologies that I just sort of talked about. Any other questions?
I'd be interested in the following weeks to find out how little data you can use, because especially things like maybe you don't have much data and you want to generate your synthetic data to train another supervised learning problem, things like that. How low could you go, kind of thing like that, with very sparse kind of data.
Yeah, and there's other data augmentation technology you can use, like flipping or zooming in and out, scaling. There's a lot of different technologies that can be used to sort of augment data to feed into your model. So we could look at that as well. Yeah. Yeah. So I would say for the next meeting, we're probably just going to look at a little bit of Python stuff. The next meeting is just going to be really sort of abstract, talk about concepts of deep learning, how it works. We'll get into more of how actually deep learning works. Have a couple games that you can play and stuff. And then we'll look at probably code and stuff after that. The two big ones unless people really struggle with NumPy, but if you could have some understanding of NumPy and Python, look a little bit at that, that would be probably useful. Yeah. I'll post the recording on ai-forall.com. There's a web page and there's a channel where this will be posted. So, discriminative modeling. That's just sort of half the problem, I guess you could say. The question was discriminative modeling. That's really more half the problem, you could say. No other questions, guys? You're all good? Okay. Well, thank you for everybody for coming out, and hope to see more of you again. And yeah, so really going to be a lot more hands-on in the coming sessions. I'm going to have to throw a bunch of exercises at you guys and stuff like that. So look forward to seeing anybody who wants to try out and participate next time. Thank you. How did we kill this?
There's a question on potential reading material.
Well, so if you go to the ai-forall.com site, there's actually a great collection of videos for people to review and look at.